so here we are going to find the inverse z transform of the signal. X of z is equal to 1 by 4 z inverse by 1 minus 1 by 2 z inverse into 1 minus 1 by 4 z inverse. Okay, and here the given ROC is that mod z is greater than 1 by 2. So from this ROC itself you can understand that this signal is a causal signal. So if it is a causal signal, then the final answer you just need to multiply the answer with u of n, right? That's all. So let's do this problem using partial fraction. So before applying partial fraction to this equation, we need to change the way how this z transform is being represented, right? Here, because here the power of z is minus 1. This is not the way you need. You need to make this format in such a way that it looks something like this. That is, for example, it should look like the denominator should have z minus a into z minus b into z minus c. See, this is how you need to see the denominator. But here you can see that that's not the way how the denominator is written. So you need to change this format into a format like this. Okay. So for that, I'm going to make a small modification over here. It is we know that this is nothing but 1 by 4 z by, and this is 1 by 1 minus 1 by 2 z into 1 minus 1 by 4 z, or this is nothing but, I can say this is nothing but z minus 1 by 2 into this is z minus 1 by 4, and this is by z, this is also by z. Okay, this z and this z will get cancelled, and this z comes on the top, so it will become z by 4 into z minus 1 by 2 into z minus 1 by 4. Now this is in the form where you can apply the partial fraction method. Okay, so partial fraction method, you can understand this is two distinct factors. So two distinct factors means two distinct answers, right? But before applying partial fraction, we need to apply the partial fraction in such a way that the denominator over here should be z, right? So that means x of z by z. You need to apply the partial fraction to this equation, not to this. You need to apply partial fraction to this equation. So this is nothing but 1 by 4 into z minus 1 by 2 into z minus 1 by 4. Now you can partially factorize this, right? Now you need to factorize this equation. So by factorizing it, you can factorize this by writing it into two separate factors, which is a by z minus 1 by 2 plus b by z minus 1 by 4. Okay, so now you need to find the value of a and b, and the process of finding the value of coefficient a and b is the same like how you did before in Laplace transform, exactly the same, no difference. So here, to find the value of a, the denominator of a is z minus 1 by 2. So that means the value of z is 1 by 2. So that means substitute the value of, after removing this denominator, here denominator is z minus 1 by 2. So remove this denominator and then substitute the value of z as 1 by 2, right? Because z minus 1 by 2 is equal to 0, therefore z is equal to 1 by 2. So remove this denominator from here, remove this term from here, and then substitute the remaining value of z with 1 by 2. Okay, so you will get 1 by 4 into 1 by 2 minus 1 by 4, which is nothing but 1 by 4 into 1 by 4, and this is nothing but 1. Okay, in the same way, now I'm going to substitute the value of b, and here b is, you can see the denominator of b is z minus 1 by 4, right? So substitute the value of z should be 1 by 4, and remove this denominator, remove this term from here, and then substitute the remaining value of z with 1 by 4. So 1 by 4 into 1 by 4 minus 1 by 2. Okay, this is nothing but 1 by 4 into 1 by 4 minus, this will be minus 1 by 4. So 4 and 4 will cancel, you will get minus 1. So you found the value of a is 1 and the value of b is minus 1. So now you can substitute these two values over here. So therefore your x of z by z is equal to 1 by z minus 1 by 2 plus minus 1 by z minus 1 by 4. In other words, so now you know why we made this x of z by z, right? Because at the numerator I need an z, At the numerator, I always need an z. So in order to protect that z only, I brought that z to the denominator of x of z. Now I can put the z back to its place. Because from here in only I can now find my inverse z transform function, right? So now we know that x of z is this value. So now I can say that x of n is nothing but z inverse of z by z minus 1 by 2 minus z inverse of z by z minus 1 by 4. Yes, and we already know what is the inverse of z by z minus a, right? We already know that. If you want, I can write it over here. So that means we know that the z inverse of z by z minus a is nothing but a raised to n u of n. So therefore x of n is equal to, let me write that again over here, z inverse into z by z minus 1 by 2 minus z inverse into of z by z minus 1 by 4. Okay, and therefore according to this equation, this is nothing but 1 by 2 raised to n u of n minus, and this is nothing but 1 by 4 raised to n u of n. This is the value of x of n. See, so this is how you do it. Okay, so the reason how I got this value is because I know the equation of this, right? The equation. The reason you are able to apply this equation is because at the numerator you need an z by z minus a. It should be looking like this. So your answer will either be in the form of z by z minus a, or it can be z by z minus a the whole square, or it can be z by z minus a the whole cube. You see, so for all those values you just need to apply its inverse and write the equation, and in all those values the numerator there will always be a single z. So in order to protect that z only, in the beginning of this process I made this z, or I divided this equation with z, x by z by z. Then I applied my partial fraction to this equation, and then I found the value of a and b, and then I substitute the value of a and b, and then I applied the inverse, and as per my equation I substituted that values of this equation, and then I got my final answer. Okay, so this is how we do the partial fraction method. Okay.